everyone, I'm Eun Yu from the University of Illinois at Chicago. Today, I'm presenting our work, Reducing the Search Space on Demand Helps Older Adults Find Mobile UI Features Quickly on par with younger adults. The HCI literature has consistently shown that older adults encounter difficulty when navigating feature-rich mobile user interfaces. They frequently struggle to identify and locate features on mobile interfaces. In an attempt to address this issue, simple and senior-friendly applications have been proposed, but their adoption remains limited, often only when there are no other options available. To assist older adults in mobile navigation, researchers, including ourselves, are exploring different types of tech support. In our previous study, we proposed a design solution that allows users to verbally inquire about interface features and provides visual cues to help narrow down the search space. Here, we found that older adults tended to use our solution after getting lost, and it helped them recover immediately after the intervention. However, we still do not know if visual cues can make older adults more efficient or accurate in mobile UI explorations, neither how to design cues that would help older adults the most. We examine these open questions here. Expanding upon prior research, we investigated how to visually augment feature-rich mobile UIs to assist older adults in feature selection. First, we established our technique for reducing the feature search space and developed a pipeline. Then, we conducted a design exploration of visual cues to communicate a reduced set of UI features to older adults through a controlled study. Following that, we introduced an interaction technique called Nav Nudge, developed based on our findings. We conducted a small-scale quantitative study to evaluate how older adults use Nav Nudge. To reduce the number of features that older adults have to search to find one, we created a feature search space reduction technique that reduces the search space of any mobile UI to 3. It first determines what function the user is looking for from a self-generated free-form verbal query. Then, it obtains a list of features available in the user's current UI view, along with their location using Android Assist API. Finally, our method compares the two sets of keywords to identify 3 features on the user's current UI view that are most relevant to them at that moment. Please refer to the paper for details on the keyword extraction method and how the number of features was selected. The following is a study on how to visualize the reduced search space for users. We evaluated 4 types of visual cues designed based on designs commonly found in onboarding or walkthrough sessions of websites or mobile applications. Highlight darkens the screen with a black overlay except for the UI elements predicted to be relevant to the user's query. Highlight with context does not darken the surrounding space of the UI elements to display their context. Zoom magnifies all 3 elements equally, while weighted zoom magnifies the 3 elements in proportion to their relevance to the user's query. To evaluate what type of visual cues would be helpful, and to test whether reducing the feature search space enhances older adults' efficiency and accuracy in mobile UI navigation, we conducted a controlled experiment with older adults and younger adults. The experiment was performed online via a responsive web application. Each task was first presented to the participants without any visual cue. If they successfully selected the correct feature that they would need to interact with to complete the task was never shown again. If no correct selection was made within a given time, The task would then reappear with some type of visual cue, randomly chosen from the 4 options. Participants were asked to complete 24 tasks. To create these tasks, we selected 6 feature-rich apps, and 4 unique screens were captured per app. The first set of 12 tasks provided only visual cues, while the subsequent 12 tasks combined spatial visual cues with 2 types of text cues. While content labels embedded in the app are strongly recommended on most platforms, they may not always be of sufficient quality. Therefore, we also considered providing manually authored instructions alongside a spatial emphasis. After completing all tasks, participants were asked to provide their preference for the different types of visual cues. 28 older adults and 28 younger adults participated. 23 of them used mobile devices and 33 used computers. Since there was no significant difference in efficiency and accuracy, we could confirm that the type of device didn't affect the results significantly. Also, there was no significant difference in familiarity with the 6 mobile application between older adults and younger adults. To investigate which type of visual feedback is most helpful for older adults, we examined the completion time. Pairwise comparisons revealed that older adults were significantly more efficient with the highlight with context feedback compared to highlight and zoom. Similarly, they were significantly more efficient with weighted zoom compared to highlight and zoom. In terms of preference, highlight with context and weighted zoom were selected as the most preferred feedback options. Additionally, no significant differences were found in error rate, and there was no significant effect observed for the type of text cues. Before analyzing the effects of the reduced search space, we examined instances where users tried to find a feature without any visual feedback. Older adults took significantly longer than younger adults to locate the correct UI feature, supporting the first part of this hypothesis. Additionally, in the absence of visual feedback, older adults made more errors before finding the correct feature, supporting the second part of the hypothesis. For our next hypothesis, we compared the performance of older adults with a reduced search space to their performance without it. As we expected, the presence of a reduced search space led to faster task completion. Additionally, we observed a significant decrease in the error rate with a reduced search space. For the last hypothesis, we compared task completion times and error rates between older and younger adults using a reduced search space. Results showed no significant differences in task completion time and error rate between 2 groups. Moreover, equivalence tests confirmed that there is no large effect of age on these 2. Therefore, both the efficiency and accuracy part of the hypothesis were supported. Based on the findings, we designed Nav Nudge, an interaction technique that reduces the search space of a feature-rich UI using visual cues and demand to nudge older adults in the right direction. When the user presses the home button on the device, Nav Nudge is activated, which is similar to how Google Assistant or Siri is activated. Then, the user can verbally ask about what they are looking for. Following a short processing period, Nav Nudge reduces the search space of features by highlighting up to 3 relevant UI elements predicted by its pipeline. With a single tap on the screen, the user can dismiss this visualization and seamlessly continue interacting with the app they were using. Here, we chose to use highlight with context and weighted zoom based on a previous study, and we used OpenAI's Text DaVinci model and Universal Sentence Encoder to implement our feature search space reduction pipeline. To evaluate Nav Nudge, we conducted a small task-focused study to explore how older adults would use Nav Nudge outside the lab in an unconstrained setting. We chose a mobile app that would be conceptually familiar to older adults, but not commonly used, called Organic Maps. Participants were asked to complete the tasks using a provided Android phone, and they had a time to adjust the screen brightness or font size according to their preferences prior to the study. No time limit was imposed for the task completion, but they were encouraged to complete it as quickly as possible. Participants were asked to do 4 tasks. Among 4 tasks, 2 tasks used highlight with context, and other 2 used weighted zoom. The order was randomized. The tasks consist of lookup activities, utilizing a hidden feature on the screen, and undoing a previous interaction. 10 older adults participated, and all participants successfully completed tasks. As we expected, all participants were familiar with map applications, but no experience with organic maps. 8 out of 10 participants asked at least one question, and in total, 19 questions were recorded during the study. Among 19 instances, 18 questions were answered properly by the Nav Nudge. One instance of failure occurred when a participant hesitated during a question, leading to the timeout. From the study, we observed 80% of participants used a voice assistant, and those participants are likely to ask a question when they were getting lost. And all intervention worked immediately, so we could confirm that Nav Nudge helped user complete the task. In summary, we first systematically examined various ways to convey a reduced search space and found that visually emphasizing 3 relevant options helped older adults find a specific feature more quickly, on par with younger adults. We also found older users were more efficient when options were highlighted along with their context or with a weighted zoom than when they just highlighted, and they also preferred these 2 the most. Based on the findings, we introduced Nav Nudge, an interaction technique that uses voice input and large language models to visually reduce the feature search space on demand, and we confirmed that older adults tended to use our solution after getting lost, and it helped them recover immediately after intervention. Thank you.